I don't know, space the waistline. So, yeah. Yeah. Let me go back to it, right? Yeah. So if you have a situation where then we have 5 meters there, right? And you have to find the result. You make use of your basic knowledge of trigonometry to find the result, right? Because I think these are nice numbers. I should say like R will be equal to um, square root over square plus. This will give you another number. Let me use 3 then. 3. Let me use 3. So I have 3 square. You get a nice, maybe 5 newtons there, right? Yeah, you have a nice number here. And if you want to find the direction of the resultant, you find this angle here. Making use of your basic, trigonometric ratios, right? I don't think you have trouble doing that. However, things can get a little more complicated when the vectors are not nice and vertical like this. When it's not nice and vertical. So maybe you have, let's say you have some force acting like that. Let's say now you have a force, you turn this way. And let's just say this one is the 3 Newton, and maybe the angle in between here. Angle in between here, let's say it's 30 degrees, right? So now if you were to, let's say you're using a triangle line, you want to go this way, right? So this is the Newton. There is a 3 Newton can be down over 4 Newton. You have a 3 Newton there. Your 3 Newton there. You want to find your resultant here. What would this angle be? If this is 30, what would this angle be?
So 120.
Think so?
150.
150. Right? So you see that kind of jolts us into some brain activity there, right? Yeah. So now you have to use maybe your cosine rule, right? I should ask you that instead of telling you that. So R will be very complicated. Now you get R equal to what? 4 square plus 3 square minus 2 times 4 times 3 cos of 150, something like that, right? The root of all of that, right? So when you see they're not horizontal or vertical, and they're at some angle and so on, things get a little more complicated, right? And you have to make use of your knowledge of geometry. Now, the thing about it is that we're used to taking a number of vectors and combining them into one, right? Or finding the resultant vector. What about instead of doing that, we do something else where we take it apart. We now do what we call, we resolve the vector into its components. Right? Let's say we want to not combine 2 or more vectors using the polygon law, but we want to know resolve vectors into components. Why would we want to do this? Why would we want to do this? Well, maybe let's say you have a body, right? You have a body. And there's a force acting on this body, force acting on the body in this direction. You say, all right, this is a nice angle. Yeah, it's 45 degrees, this force is acting on his body, and the force makes, think of it like a body and there's a rope or something like that, pulling at his body. And the rope makes a 45-degree with the horizontal. Now, instead of, let's say you're given the question that you have to determine whether this body is going to be lifted off the ground or it will simply drag horizontally, right? And again, I'm oversimplifying the situation, right? I'm saying that when you pull this body with this force, that force is enough to overcome the frictional force. Let's see, okay, friction is I can't use F on it. Let me call this P. And there's a force pulling the body, and there's a frictional force that is going to work against this body moving, right? And then there's weight, right? And there's the weight of the body, right? So you next have to figure out, well, there's also a force acting on this body by the ground, which is called a reaction force. Now, things are getting complicated here now. And you want to know, well, okay, is this force P, is it enough? Is it enough to drag this body along the horizontal? And I think you've all been in this situation, right? I think you've all been in a situation where you're trying to drag something like that. You don't pull the thing horizontally, right? You don't pull the thing horizontally. Usually you rope or whatever you have pulling it. It's always at some angle, right? Maybe not 45. You're a little small, you're your height there. You're tall and Jig is small. We're not going to, I don't want to complicate the whole situation. Have you ever been in a situation where you're pulling something like that? Let me know if you're there,
Yes, sir. I drag my toddler often to the bathroom, so.
What I like is in physics, we don't care what the object is, right? That's for the social worker and the psychologists and the psychiatrists to deal with, right? If it's a toddler, well, they will be involved. But we're doing physics, so yeah, we can use your toddler as an example. Yeah, so let's say you're posed with a question like this. What are you going to do? Tell me your thoughts. How do you determine whether that force P is enough to pull this body horizontally? How do you know? Any thoughts? What I want to lead up to is why there's that need for us to know how to break this force P up into what we call components. Why there's that need. Any thoughts? What would be your analysis of the situation, and what do you suggest we do? Any ideas? If you don't have an idea, say that you don't have an idea, right?
Yes, sir. I'm not sure if the answer is correct, but the fact that the force is acting in an angle is going to get a vertical component and also a horizontal component. And I think if the vertical component is greater than the weight, it may lift it off the ground, but if not, it may drag it horizontally. I'm not sure.
Yeah, you're onto something there. That's a good analysis, right? That's a good analysis. Okay. Now what we normally do with this force, we kind of break it into two parts, right? So we take it and we break it into two parts and say, okay, let this be P with a subscript V here. And then we break it into a horizontal component, get P a little H here, you know? And your analysis will depend, or rather, your conclusion is going to be based on this analysis. If pH is greater than F, then the body is going to move that way with some kind of acceleration, right? It's going to accelerate and start to move that way. If PV plus R is greater than W, the body is going to again, you know, kind of move upwards, right? See that? Right? If on the other hand, PV plus R is less than W, what will happen is that the body is just going to be moving horizontally, right? Because the weight is keeping it on the ground. The weight is greater than those two forces lifting it up, right? So the body is going to move this way. But you note that the whole analysis of this problem depends on our taking P and breaking it up into its components, because to work with P as it is, I'm not saying that you can analyze this problem with P being an angle there. I'm not saying that, right? You can actually use the polygon or the polygon law and find the resultant, right? And draw a conclusion. You can. It just might be a little more difficult, right? And what you can do, and that's where, you know, you are teachers, you can sit down and put numbers to P and R and F and W and so on, and see what happens, right? When you use the polygon law, how complex things will be. So what we will do is we're going to remove this diagram now. We're going to talk about, remember, we're not analyzing this problem or say, you know, right? What we're going to do is talk about how can we take P and break it up into what we call the horizontal or vertical components, right? So let's do that. And I just want to mention this. It's not that I'll tell you, I don't like to be recorded, right? I don't know what you will do with my recording, right? UG is just encroaching on my rights by telling me I must record myself. I'm also suspecting that students, there are students who can't make the class. They have to be here for the tutorial. I can tell you that. But I also suspect that sometimes it's a problem of people not being able to take good notes. They haven't learned the art of note taking, right? And therefore, they think that all I'll do is like I do in YouTube and all that. I just go back to that part of. I've done a few courses of recent, and when I'm in the test, you don't have time to go back to your video and see what the man said. You know? Yeah. So let's say this is P. And the angle that P makes with down here, let's call it alpha. Right? If you were to use your little bit of trigonometry knowledge, right? If you were to use your trigonometry knowledge, you will see that this component of P, right? If you want to call it P subscript H, is equals to P cos alpha, right? And I want you to, if you, this is what is puzzling you, how did I come up with that, right? I want you to go back to your little bit of trigonometry and verify these are different color. And the component of P this way, let's call this P PV, is equals to P sine alpha, right? So what you can actually do is you can break P here now into two of its components, right? And not to say these are only two components, you have an infinite number of components, right? You could break P up. You could actually say what P is in this direction. You could say what P is in this direction. I don't want to complicate the diagram, right? You could resolve P in any direction, right? But in resolving P in a particular direction, basically it's P times cos of the angle, right? It's P times cos of the angle. The reason why we got sine here, because this is what, 90 minus alpha, right? So P cos of 90 minus alpha is really equal to P sine alpha, right? And I think you did two courses in trigonometry and analytic geometry, right? So you should say, sorry, you're boring. Let's move on, right? Don't ask me how that is. You have to figure that out. So that's how you can take a force and resolve it into, as a matter of fact, any component you want. Very often, to simplify, these real world problems as much as possible, we can very well either do a resolution of the force in the vertical direction or in the horizontal direction. There are other cases where, let's say you have an object on an inclined plane, right? And maybe the weight is acting this way, right? The reaction is acting that way. Maybe you will resolve this weight this way, and I think this is, what is it? Right? The weight will have a component this way, right? And the weight will act this way, right? So I think this is going to be W cos alpha. I think this one is going to be W sine alpha, right? And if you want to know, well, will this object slide down? Right? Well, of course, there's a frictional force acting that way. You have to figure out F minus I should say the other way around. If I call W sine alpha minus F, if that's a frictional force, and if I should say if that is greater than F, well, then the object is going to slide down the inclined plane. So in this case, sometimes it's not, you're not going to look at the vertical and the horizontal component, but we're looking at the component of a force that is perpendicular to the inclined plane and parallel to the inclined plane, right? So not always you're doing it or you're resolving a force in the horizontal component and vertical mode, right? You may have a situation where you might have an inclined plane you're working with, an object is lying on it, and the better thing might be to, and I'm not saying you can't do it horizontally and vertically, you can, but it might be simpler for you to analyze the situation and deal with the plane of itself, and you resolve vertical to the plane or horizontal to the plane, which is not vertical and horizontal, but the plane is inclined, right? So being able to resolve a vector into its components is very useful in analyzing the forces acting on a body, whether be it the body is on some horizontal ground, or it can be even in the air, or it's on some inclined plane, You know, very important that you are able to resolve a vector into its component. It's not just forces. I mean, let me tell you, you can have a situation where you're dealing with velocities as well. Right? Move out of this. Let me use a situation. Let us say, I don't know if any one of you is old enough. You all ever cross the ferry? You all ever cross with the ferry? So let's say
Yes,
in
sir.
Amsterdam.
Yes, sir.
Yes, sir.
Oh yeah, huh? Y'all are big enough to know that. All right, this is New Amsterdam Stella. I think Rosignol they go this way, right? Rosignol, Stella, right? I can't write anything like that. So y'all ever notice when the boat leaves, right? You would think, and I always used to want to know what is this guy doing who's piloting the boat? Why doesn't he just point the boat to Rosignol and go down? Does he do that? Oh, y'all
No,
were
sir.
when you were in the boat, right? You don't know what's happening.
So it's traveling like an angle,
Does it?
contrary to the action.
Okay, it's not like this, right?
They don't go in the same angle.
He doesn't point the boat in that direction. No.
No, it don't be in a straight line.
He would probably point the boat maybe like something like this, right? Right? You point the boat in that direction and going at, let's say, 5 km per hour, right? But then remember there's a current. Maybe the water now is flowing at, let's say, put it a little bigger than that, km per hour, right? So the end result is that, okay, if I were to take this here and put it here, I'm doing it live, trying to be, forgive me for that. It's not really step. This is 2 km per hour. And the end result is the man end up, right? The resultant is he ends up heading straight to Rosignol, right? So he's not pointing. I just want to know why is he heading across almost straight? Sometimes you don't see this angle and all. He seems to be putting the ferry almost like straight. And you say, what is this guy doing? We're not going to the factory at Blaymont here. But then what happens is that the velocity of the current, the river itself has a certain velocity pushing the boat, right? And the end result is that you see the boat reaches Rosignol Stella, right? So, sometimes the resolution of vectors now come into play now. Let's say, all right, let's go with a situation. I just use this to, show you that you can have situations where you have yeah. Let's get a more complicated situation, all right? So you have I'll remove all of this just to give you some more space. So you have a little boat. You have a little boat. And it's heading across that way with a speed of, let's say, 5 km per hour. Then the current is tugging at it with, let's say, 2 km per hour. And then there's a wind. There's a wind now. Right? So most of you would know that if the current is falling, right, in this direction, which side the breeze gonna blow from? That way or this way? See if you're observant. So if the current is falling this way, where do you think the breeze is going to blow from? That way, this way, which way? You think? Any suggestions? The boat is heading across, the current is running this way. How do you think the breeze will be blowing? I'm talking about a river there.
Sorry, the opposite direction.
The breezes blow opposite to the current.
Sorry, I'm not really sure. Sorry, yes, I give a guess. I know the current does work.
I want an educated guess. We're doing physics. Educated guess. You all just notice, you see, that's the thing, you all might be doing these things on book and in a book. And you all ever pay attention to older folks talking? And you ever see that, or you ever hear an older folk telling you the tide falling now? And he's basing it on wind direction?
Yes, sir.
Yeah, you can tell when the tide is falling and when it's washing, they call it, right? Washing is when it's coming up. Right? The breeze usually come with the tide, right? So if there's this, perhaps the breeze is going to blow this way, right? Let's just say it's also going a little faster than the tide, no? Would it be 3 km per hour, right? So now you have a situation, you wonder, well, what will be the resultant velocity of this boat? So the boat, the engine is producing a velocity of 5 km per hour, right? Going, as we see here, it's going in this direction. Current is tugging at the boat this way. And then there's a wind coming from this direction, going that way, right? By the way, you almost notice these things in it. You almost notice things like when the tide is falling, where is the breeze heading? Right, where it's coming from, where it's going. When the tide is rushing, you can't live, you can't make decisions if you don't know these things. And I'll tell you a quick story. When I made this house, I didn't have water, right? For many, many, many years, I didn't have water. I'm talking about from Guyana. And you know why I never connected to Guyana for more than 14 years? I lived without Guyana for 14 years. I was listening to an old man. I was teaching a class in New Amsterdam. So there's this old man. He was waiting to go in to do something in a business office. He's standing there. And he's talking about when he's going to sow his paddy. And he said he's waiting for the new moon. I said, what is he talking about? He says that there's, whenever you have a new moon, 3 days before, 3 days after, within that time span, he didn't use those words. He was talking in a very broken down Creole, You expect rain, right? And usually the farmer would save money if there's rain, because instead of irrigating the field, you'll get free water from God. And it's going to be laden with a lot of fertilizer in it. And I didn't know that, right? Because rainwater is full of nitrogen inside. I don't know if you know that idea, right? And I've subsequently learned also that when there is a full moon, and I've observed it, that you also get some rain, and the probability of rain, like about a day or two, maybe 3 days before and after a full moon, you get rain. And I decided to look what I'm not going to take that. And I decided to build this place I'm in here, this little trestle. up top there got 4 tanks and that big vat. And when the rain fell at those times, I didn't need guide for 14 years. But I noticed from 2014 that whole idea of rain falling to the new moon and full moon, it doesn't happen anymore. Right? So I had to go and get guide more. But it worked for many, many years. But I'm just saying that, for 14 years, I survived on that bit of science that the old man talked about, right? I'll tell you a little bit another one. My brother-in-law, they usually work on the sea, right? They catch fish. So he tells me when you see the moon is between from the time it is born to when it's overhead, directly overhead, you won't get fish at sea. And from the time it goes beyond from overhead, I'm talking about the evening, well, then the fish is going to cut off, unfortunately, you're going to get no fish. He said, what? So what I usually do is when you see the moon born to when it's overhead, fish sells cheap. So I buy fish then. And as soon as the moon reaches overhead and starts to wane the other direction, you don't get fish. Fish is very expensive. So you have to go and either use the fish you bought earlier or you use meat. Sometimes you watch these folks, fisher folks, people who do farming and you think what they're talking about, and you dismiss a lot of what they know, it's what we call folk knowledge, right? But it's a lot of science, right? You almost dismiss them. And that's what I'm telling you, that if the current is actually falling, you tend to have a breeze that is going, it might not go in the direction exactly as the current, but it's going to kind of help the current. It's going to go in the direction of the current somehow. Right? Yeah. Good. So now in a situation like this, let's say you want to know what's the resultant. Right? I know we just talked about the polygon law of vectors, and you can very well say, let's make a polygon, right? And you can do that. You can use the polygon law, so you can go 5 that way. 5. I'm gonna leave out here. Then you can go to 2 there, and then you can go to 3 here, right? And then you can join it like this here. And that's going to be your resultant velocity, right? Making whether if you want to find this angle, and so you can do that, right? Alternatively, you can use your knowledge of components now. You can probably take this 3 km per hour, and you can resolve it, right? This is what you can do. Let's actually resolve it and see what happens, right? I'm not going to actually use an angle. I'm going to put an angle. So let's say, all right, it makes an angle of alpha there, right? So what you're going to do is that you're going to end up like this. You have the 5 going that way. The bolt is here. You're going to resolve this 3 downwards, and you're going to get 3 sine alpha. And then you're going to go this way. Right? So this is what 2. And you're going to resolve this way, right? And you're going to get what? 3 cos alpha, right? See that? So if you were to take this now and reduce it now to just 2 vectors, you get this. Down here will be 5 minus 3 sine alpha, right? And I put this here because 3 sine alpha will always be less than 5, right? And then down here we'll have 2 plus geometry cos alpha, right? And now you have a situation where you can easily complete your parallelogram. You're not dealing with a complex polygon anymore, right? And you can find your R, right? You can find your R because this is going to be a number, that's going to be a number. And you use Pythagoras theorem and find R, right? So here you have an alternative situation, right? Where where you use the polygon law, you may have some complex trigonometry to do, right? And it might take you a longer time, but if you can resolve, in particular, this 3 km, right? This 3 km here, if you can resolve it and take it away from this and add it to that, right? As you see me doing here. And then you end up with a simple, very simple triangle, which is a right angle triangle. And you're able to calculate the result very simply, right? So being able to resolve a vector into its components can have a number of uses. This is just one, right? So that ability you want to practice and make use of it in problems. You can use the vector law of addition, that is the polygon laws, the triangle law, the parallelogram law, or the polygon law as a whole, right? If you're dealing with 2 or more vectors. But then you can also make use of the components of a vector to simplify a problem, right? So those are the reasons why, you know, I want to go through back vectors, their addition, vector subtraction is basically addition of vectors, but one of them might be negative, and so that's what it is, right? Yeah. So you would need that. You need that bit in order to solve a lot of problems involving vectors. You know, vectors can be a force, it can be a number of forces, or it can be velocities, right? And those are the ones you'll be mainly concerned with, right? Good.